So this is our MRS21 Fall 2020 final review. so, uh, ladies and gentlemen, I hope these questions are helpful to you as you're getting ready for your final. And your final will look very similar to these questions, though. So just be prepared for being able to watch these, examples in case you're struggling with some of these things. Hopefully, they're helpful to you. All right. And of course, watch them over again, pause the video, go through this and everything, and make sure that you follow the steps involved. So question number one says solve for b to the nearest hundredth. And so the idea is that we're going to take this and we're going to rewrite this log function into an exponential function. So we use our template of log base b of x, x equals y, that's good, becomes b to the y equals x. And so our b value is still going to be b. So we have b. Our exponent would be 5, and we're setting this to 129. So this will be the first step involved for your question, and very important to be able to show this to go from this log function to an exponential a log equation to an exponential equation. Now, to solve this, we normally are going to raise both sides to the reciprocal of the exponent. So we'll raise both sides to the 1/5 power. So that means b is equal to 129 to the 1/5 power, which if I ask for a radical form, this would be the 5th root of 129. But since we are going to be looking for the value b to the nearest hundredth, we're going to find this numerical value of 129 to the 1/5 power, basically to the nearest hundredth. And nearest hundredth really means 2 decimal places. Okay, nearest tenth is 1 decimal place, nearest hundredth is 2 decimal places, and nearest thousandth is 3 decimal places. We're going to pull up our graphing calculator and take 129 raised to the 1/5 power. And yes, your calculator will do the work, but you need to show what you're typing into the calculator. So without any work shown, you're not going to get the full credit for the question. So 129 to 1/5 power becomes 2.643, which we round off to, let's go back to here. So the base is equal to 2.643 and some more decimals. But rounding up to nearest hundredth, we'll take our answer to be 2.64. And this will be the answer here. Make sure you box your answer too, so I know what number to look at. Okay, so make sure your work is straightforward, showing everything in this case. Express the following fraction in simplest radical form. Okay, so the idea here is that the exponent affects what it touches. And so we will have the following. Well, and we're going to change everything after we simplify our exponents. So we have 2 times x to the 3/2. So really, this is 2 times x to the 3/2. Now you see, why am I breaking these off? I want to be very clear that the 2 is not being raised to 3/2 because it's not being, the exponent is only touching the x. However, for the denominator, we have 16 times x to the 4th raised to the 1/4. So each of these will be almost like distributing the exponents to each of the terms, each of these numbers here. And so we'll have 16 to the 1/4 power times x to the 4th raised to the 1/4 power. And so we'll simplify now. Well, we have 2 in our numerator times x to the 3/2. That's totally okay. Well, 16 to the 1/4. Now 16 to the 1/4, we can rewrite 16 as 2 to the 4th power. So 2 to the 4th power raised to the 1/4, that's just going to be plain old 2. Because when you raise a power to the power, we multiply exponents. And the same way, x to the fourth raised to the 1/4, we're going to multiply these exponents, and we're going to get x to the first power. Now, you don't have to put the first power like 1 down, but I'd like to put it there. Now we're going to simplify. Well, 2 divided by 2 just becomes 1. And x to the 3/2 divided by x to the first really becomes x to the 3/2 minus 1, because when you divide two numbers the same base, you keep the base and subtract exponents. So this becomes 1 times x to the 1/2. Now, simplest radical form, if we remember in this case, is that x to the a over b becomes the bth root of x to the a. That's one of those things we learned about changing the exponent to a radical and radical to exponent. And so 1 is just 1, so it's not a big deal, but the 1/2 power means we're going to have a radical here. The index is 2, and we have the exponent for the radicand x is 1, so our answer is going to be the square root of x. And that's what this expression is going to simplify out to in simplest radical form. The value of x in the equation 4 to the 2x plus 5 equals a to 3x is, we want to solve for x, and we must solve algebraically. And we learned before, when you have exponential equation, the goal really is to try to get the bases equal to each other. Now, it'd be great if we could write down 8 as a base 4, but that's not possible. 4 the first power is going to be 1, 4 the second power is 16, so can't get 8. But instead, we will change 4 to a smaller base, which is base 2. Really, 4 is really 2 to the second power. And 8 is going to be 2 to the third power. So now we have 2 squared raised to 2x plus 5 equals 2 to the third raised to 3x. The goal is to get the two sides have the same base to each other. All right, and we did. Now we're going to distribute the 2 here, and the 3 will multiply with 3x, and we're going to get, in this case, 2 to the 4x plus 10, be very careful to distribute, equals 2 to the 9x. And we have learned that in exponential equation, if the two bases are equal to each other on both sides, then the exponents must be equal to each other. So we will now use the exponents 4x plus 10 equal to 9x to now solve the equation. Subtract 4x on both sides. We get 10 is equal to 5x. Divide both sides by 5. Our x value is equal to 2. Okay? All right. There you go. So, ladies and gentlemen, this will be the end of our final review, part 1, and we'll continue with the other questions in part 2, and hopefully not necessarily have to go to part 3, but hopefully you can watch these over again if you find them helpful. Definitely give this video a like, appreciate it and all, and of course leave any questions or comments in the comment section below. This is sort of a guide to help you out, for those of you who are really struggling with the math. And our finals questions will be very similar to this, so it's not really a surprise in this case. If you're, make sure to show all the work though, very important. If we only see answers without work shown, we'll not get full credit though. Anyway, thanks for watching, ladies and gentlemen. I will see you in the next video. Take care and be safe.